This video is going to clue you in on the special types of linear systems. The types that we have been doing have all come out with one ordered pair, which means that the two lines cross each other, but those are not the only types of lines that you will experience. There are two special ones, and so this chart will show us all three of them, and there's also going to be some new vocabulary that you'll have to make sure that you remember and understand as well. Right, so there's a description column and a number of solutions column, right? And we're going to take a look at the picture that goes along with each one. Your first graph shows you two lines that cross each other at one point, which is a lot like the ones we've been doing in class, where that one point of intersection is the answer. So for the number of solutions, there is exactly one. And that one solution is always an ordered pair. Now, along with the number of solutions, you'll have to identify how many a system has just by knowing some characteristics, but you'll also have to be able to describe it based on some other vocabulary words. So these next words that I'm getting ready to give you are some descriptions as well as vocabulary that just pertains to systems in general, right? So in terms of describing this graph, it is two intersecting lines. And because it is two lines that intersect each other, there are two vocabulary words that fit along with a system that does this. The first one is that any system that crosses at one point is known to be consistent. Okay. And basically what you need to remember with consistent is that it consistently touches in one spot. It's all about how often it touches. Okay. And then independent is the other description. Okay, and the reason or the way you can know that it's independent is because it's two independent lines that made this picture happen. So consistent deals with the amount of times it touches the other line, and independent deals with how many lines exist. Right. Your next graph you'll see are two parallel lines. So the description will be two parallel lines, and that's how you know when this is going to occur. Okay. And the vocabulary that goes along with this, there's only one word to remember, right? These lines in this system are what are known to be inconsistent. Right? And remember I told you consistency deals with how many times it touches. Well, in parallel lines, they never touch, so they're said to be inconsistent. Right? In terms of number of solutions, if it never touches, there are no solutions. Right? So the amount of solutions will be none. And when you're solving equations, the way you're going to know that you're going to have no solution is it'll give you 0 on one side and it'll equal some other random number on the other side. When those two don't match, you know you have no solution, just like when we solve equations normally. Right? The third and final type of system that you're going to be dealing with and identifying looks like it's only one line, but there's really two lines there. And the reason is because they are overlapping. So this is when both equations make the same line. So literally it is one line that has overlapped itself, right? But it's two equations that actually make the same line. And the vocabulary that goes along with this, right, is because it touches everywhere, it is definitely a consistent system. Okay? And then instead of independent, this is going to be a dependent system. And that's because the one line that is there depends on the other line to overlap it. That's an easy way for you to remember it. Okay, in terms of number of solutions, since it overlaps and touches everywhere, that means it has infinite solutions. There's no limit to how many solutions you can get off of it. And when you go to solve these systems, you're going to find out that you'll end up with 0 equals 0. And if you stop and look at it closely enough, or if you scoot your numbers closer to your equal sign, it resembles the infinity sign. So that's an easy way for you to remember which one's which. All right, now there's two methods for determining how many solutions you have. Right? The first one is by ratios. And I'll be honest, I never was taught this way. When I was in school, I was taught the way that you'll see on the back, but the ratio way is very easy to do once you've memorized which one goes with which. Right? So I'm going to see if I can help you remember and find a way that it sticks. If it doesn't stick this way, then you have to resort to the way that I'm going to show you on the back side. Right? So the first one tells you that you have intersecting lines when the ratios of the coefficients are different. So what you have to do is take the ratios of just the coefficients. So in this case, the coefficients would be the 2 and the 4 for the x, and the 4 and the 3 for the y. If I make a ratio out of each one of those, I have 2 over 4, okay, which makes 1/2. And then for the y's, I have 4 over 3, which does not make 1/2. So when those ratios are different, this one and this one, right, then you know you're going to have intersecting lines. And when you have intersecting lines, you're going to always have one solution. So this one will give you one solution, which means you will have an ordered pair off of this. Okay, for the next one, parallel lines occur if the ratios of the coefficients of the variables are the same, just the variables. Right? So again, I'm going to take the coefficients of the x and the coefficients of the y, and I'm going to take a look at those ratios. I have 2 over 4, which is 1/2, and I have 4 over 8, which is also 1/2. When those two ratios are the same, then you know you will have parallel lines. And if you have parallel lines, you have no solution, because they're never going to cross. Okay, and then if you look at the third one, coincident lines, which happens to mean that they are coincidentally the same line, okay, they occur when the ratios of the coefficients and the constants are the same. So every number in this problem sets this up as a ratio and has to be equal. So the 2 and the 4 and the 8, and the 5 and the 10 all have to be the same, or it's not going to be the same line or overlapping line. So if you have 2 over 4, that's 1/2. 4 over 8 is also 1/2, and then we have 5 over 10, which is also 1/2. So since all three of these are exactly the same, then in this case you're going to have infinite solutions. That will be 2 overlapping lines because it's exactly the same line. So if you can learn the ratio way and remember which one's which, it actually saves you some time and a lot of work on your paper. But if you can't remember that, flip your paper over to the back side. I'm going to show you how you go ahead and solve the systems through elimination, and you can come up with the same result. All right? So if you look at the first one, right, we're going to take and solve it by elimination, which means we need to eliminate one of the letters. I'm going to multiply the bottom equation by -2 so that I can cross off the y's. When I do that, that gives me, let me rewrite the first one so you can see what's happening. After multiplying the second one by -2, I'm going to have positive 6x minus 2y equals -14. Here's how you know when you have a special case. When you go to eliminate, you notice all of your letters eliminate. That leaves you with 0 on the left-hand side equals -8 minus 14 is -22. When those two numbers are different, that's going to automatically clue you in that this is a no solution system. Okay, and with no solution systems, that means that they are parallel lines,